Good day everyone. So for today's video, we will talk about how to give science lessons a real world boost. So first, let us know who is Judy Danehammer. So she is a science teacher. So Mrs. Danehammer believes that we should challenge our students with authentic real world issues and give them a platform to make a difference in society. She also believes that we should focus not on preparing our kids for what is next but on helping them make a contribution each and every day. Teachers can inject new life into old labs by adding elements that prompt students to show creativity and make connection to prior learning. According to Dinheimer, that if you were to peek into a science classroom today, do you think it would look the same as when you were a student? When she was in high school, it was notes, lab, test, repeat. Today, many science classrooms are interactive, exploratory, and creative. Kids are developing experimental plans, drawing conclusions based on evidence, and creating their knowledge with the world. Some of those old science labs and activity ideas were good but maybe too prescriptive. As students, we all did the same thing and had the same end product, similar to following a recipe to bake a cake. How can we as educators take those original ideas and update them to meet the needs of our students today so that they are motivated and engaged in our classroom? So there are 4 examples of updated science lessons that hold students' interest. First, design a lab around a guiding question. Original lab: soak a dry chicken bone in vinegar overnight and see how the density changes. Updated version: develop an experiment that explores an environmental impact on bone density over time. To implement this idea in your classroom, start with a guiding question. For example, how do everyday choices alter bone density? Give students a good database to use and let them quickly research these questions. Have each group share out what they found and generate a list of questions they still have. The goal is for them to have more questions than answers at this point. Challenge each group to develop their own more specific guiding questions that they will use to launch an investigation. To help develop a procedure for testing their guiding questions, we should incorporate time for them to present their procedures to the class to gain their feedback. Next, students run their experiment and collect data. They create charts and graphs and analyze the result. Once the lab is complete, they develop conclusions based on evidence and prepare to share their findings with others. We should challenge students to create product that shares this information in a way that encourages others to keep bones strong and healthy. As suggestions for creating infographics using Canva. So Canva is a free-to-use online graphics tool that combines design, photo editing, and layout to help teachers and students create beautifully finished projects. Recording short video public service announcement using clips or creating a breaking news article using Creative Cloud Express or Pages. Second, annotated dissections. Original lab: dissect the specimen and label the diagrams in the packet. Updated version: create an annotated image of your specimen to identify at least 5 structures. Instead of labeling a stock photo of the brain with arrows pointing out specific structures, have students to take picture of the specimen and their table and label at least 5 things they can clearly identify. Tell the students to be prepared to explain how they know what they are pointing out. Third, sketch note writing summaries. Original love, read the article and write a summary of what you've learned. Updated version, read the article and create a sketch note that shows how the information you are reading relates to your life and what we have learned previously. As students work through the scientific paper, they take notes on things they think are most important and then create small sketches or drawings that help them solidify the concepts. It shows the variety of work that it is submitted and how the students are able to make deeper connection to the content they are reading. They start to show how the information pertains to them as an individual. Fourth, seed studies. Adopt a plant. Original love, look at seeds and determine their method of dispersal. Updated version, plant seeds and measure plant growth over time. Set up and adapt a plant program at school. Students will motivate if they are part of the process of the experiment. For example, in 7th grade science, students selected a seed to plant. We studied the seed and determined its method of dispersal and researched its needs to germinate. Students then planted the seeds and cared for the plant for about 2 weeks. We asked the teachers and school to adopt a plant from a student to take home and grow. Students created a guide for their plant to share with the teacher. This guide gave the teacher all the information they needed, such as sunlight and water requirements, as well as other information the students thought the teachers might find interesting. When students are developing labs, creating their own images, teaching others and applying what they have learned to their own life, they more engaged in the content. As for educators, then we're always looking to challenge our students to dig a little deeper and make more meaningful connection to our curriculum. And that is all for today about how to give science lessons a real-world boost and a for example of a dated science lesson that holds students' interest. Thank you for watching and listening.